In my third video on implicit differentiation, I'm now looking at sort of a funky curve with trig, and I have this parentheses squared, which looks like kind of like a chain rule, or you could FOIL it out. So here's what I'm going to do. I'm going to take the derivative with respect to x. So when I first take stock of a problem, I go, all right, is this good? Sure. Is this good? It's a little weird. It's got a y. So I know I'm going to have to tag it with the dy dx. Then I look over here, and I'm either going to have to do chain rule on this, or I'd want to FOIL it out first and then take the derivative. Okay. I'm going to go ahead and use chain rule just so you can see that in action. So here we go. I'm going to take the derivative with respect to x. All right. The derivative of sine is cosine, and it's an x, so it gets to just chill. The derivative of cosine y is negative sine y, but y is not an x, so I have to tag it with a dy dx. Remember, if it's a y, you have to tag the dy dx. Okay, so this side is good. All right, over here, to do chain rule, I would go 2x plus y to the first. But I have to take the derivative of the inside. The derivative of x is 1. The derivative of y is 1 dy dx. So it's going to look like 1 plus dy dx. Okay. Now, I have got to solve this for dy dx. So this side is good to go to start moving, but this one I'm going to have to clean it up. So I'm going to distribute the 2 through as well as FOIL it out. So let's see what's going to happen here. This would be 2x plus 2y. And then when I FOIL it out with this piece, I'm going to have 2x plus 2x dy dx plus 2y plus 2y dy dx. Okay, so this 2 I distributed, and then I'm foiling it to this piece. Okay, all right, it's a bit of a mess. I've kind of slanted on the board, but that's okay. All right, and I still have my cosine x minus sine y dy dx. Okay. All right, let's do it. So you can move things any way you want. I'm going to move the dy dx's this way since I can have more room, even though it'll be negative. So this minus sine y staying, I'm going to move the 2x over and the 2y over. The cosine's going to go the other way. So let's talk about what's on this side. I'm going to have this 2x plus 2y subtracting a cosine. Okay. All right, on this side, I'll have the negative sine dy dx. Negative sine y. I got so in a hurry, I forgot the y. Okay, great. I'm going to move this 2x and this 2y over. So minus 2x dy dx. Oh, and I need it. No, I can squish it in. Dy dx. Okay. Now, we're going to factor out the dy dx's. And then divide by what's left. So if you look at what's left, I'll have a negative sine y, a negative 2x, and a negative 2y. All right, so I'm going to do it all in one fell swoop. So I'll have 2x plus 2y minus cosine x over... Okay, when I factor this out, I'll have a negative sine y, a negative 2x, and negative 2y. You're going to be tempted to cross stuff off. You actually can't, okay? All of these pieces are married together. All of these are married together. So that's our answer. Okay. And this actually brings me to a very important point. Let's say that you got this as your answer. You look at the back of the book and everything is the opposite. What do I mean by everything is the opposite? Hold on while I grab a different color pen. When I say that everything's the opposite, I mean that if you check in the back of the book, you see a negative, a plus, a plus, a plus, a plus. If you see a problem where every single sign is the opposite of what your answer is, you actually have the same exact thing. The reason why is what happened is that in that instance where we were solving, they moved everything to the other side of the equation. Okay, so if everything is off by the exact opposite sign, your answer is exactly the same. All right, I hope that example helps. It's a little bit messy with some trig and some funkiness, but that is how we do implicit differentiation involving trig and chain rule.